All right, Kanice 310, this is your final exam review, exam 4, or unit 4. I tried to record the lecture on Friday, but when I went to upload it, there were 10 seconds in the video. So obviously it didn't record, and I had some students ask for it to be recorded. So for that, I apologize. I tried. Sometimes things happen. So what I'm going to do, ooh, creepy ghost. Um, I'm going to try to summarize what we went over. Keep it simple for your Unit 4 test, muscles, contractions, and how they influence movement. Okay. I also went over with the class kind of maybe to help understand the contractions and how I'm teaching you to prove for contractions. Contractions are solved for muscles, the agonist, the muscles doing a job, influence movements, joint motion, what we spent 2.5 months on through contraction. So the last part of the class is contractions because the middle part, the joint motions, we spent the most time seeing. And if you can see through joint motions what muscles you need, then contractions kind of solve for them. So the first thing we led off with was negatives. Why is eccentrics called negatives? And the reason is because the physiological work of the muscle, their direction of pull, is kind of always positive. Like it's like an on switch on a light. You turn the light on, it's doing a job. So for the example in class, I said when you're doing curls, those elbow flexion pullers, which is more than just your bicep, brachialis, brachioradialis, but they're emphasized in red. That would be like on. They're turned on. They're working physiologically. And they're going to be working physiologically regardless of if they're isometrically holding that position or concentrically going from this position to that position or flexion. And they're going to be working eccentrically when you do the extension. So in other words, they're always working above resting tone because gravity is constantly trying to extend you or keep you extended. Okay. So you have the agonist, which I taught you how to find. That's kind of always a positive because those muscles are working. They're doing a job above resting tone. The motion is what tells you or what hints at the contraction. So if the motion is also positive, that's mechanical work. In class, I lifted up a book on the table and I did positive work on the book because I went up, and then I did negative work on the book. I lowered it down. So if the flexion is happening with muscles that are trying to flex you, that are flexion pulling muscles, those are two positives. The movement is happening in the same direction as the muscles pull that's doing a job, that's on, the light switch is on. So the extension pulling muscles, their light switch would be off. You don't need those muscles for this exercise. You got gravity already trying to extend you. Okay. So that's where this would be a positive because the positive elbow flexors are doing positive work. If you do extension with the flexors on, with their light switch on, positive, you have positive physiological work, but you have negative mechanical work, movement in the opposite direction. So the positive times the negative is a negative. So that's how eccentrics become negatives. Okay. So that's kind of what we talked about for this exercise. So for the test, I'm not going to ask you slowing down, speeding up in terms of what's greater than what. That was just too confusing. Okay. You have to identify contraction. You have to identify agonist. You have to identify plyometric sequence in layman's terms, meaning where would the plyometric sequence be in this exercise when the dumbbells are at their highest or their lowest? When will you have eccentric followed by concentric in regard to a change of direction? Here I had concentric, so it can't be at the top part because I'm going to have concentric followed by eccentric. Down here, I'm going to have eccentric followed by concentric because plyometrics is a sequence of muscle contraction, not a specific muscle contraction. Make sense? So for your final exam, all the lectures are posted on Moodle. You're going to have to identify agonist. There's as many agonistic groups as there are joint motions. We group them based on directional pull so that I can teach you how to see how muscles influence motion. If all we did was jump to pecs and tris and lats, and first of all, we'd lose track of all kinds of other muscles that assist those muscles, but the latissimus dorsi doesn't tell me how it's pulling. But if I say the latissimus dorsi is a shoulder adduction puller, or an extension puller, or an internal rotation puller, then that makes more sense in terms of how it's going to influence motion. So before, in biomechanics, we're going to get into those specific muscle names. But before we do, we have to understand how and why they do what they do. That skeletal muscles influence our joint motions through specific contractions. Okay. That's what exam or unit 4 is on. I hope this helps.